Imagine the Earth as a giant jigsaw puzzle, but instead of staying still, the pieces are constantly moving, colliding, and reshaping our planet. This is the story of plate tectonics, the science behind why mountains rise, earthquakes shake, and volcanoes erupt. Let's dive in. To understand plate tectonics, we need to take a journey to the center of the Earth. Our planet is made up of layers: the solid inner core, the molten outer core, the semi-fluid mantle, and the thin, rigid crust we live on. It's the crust and the upper part of the mantle, called the lithosphere, that break into giant pieces called tectonic plates. These plates aren't fixed. They float on the softer, semi-fluid part of the mantle, called the asthenosphere. Heat from the Earth's core creates convection currents, pushing and pulling the plates in different directions. This movement is what drives plate tectonics. Let's start with divergent boundaries. This is where plates move apart, creating gaps. Magma rises to fill these gaps, forming new crust. You can see this happening at mid-ocean ridges like the Mid-Atlantic Ridge, where the ocean floor is literally spreading apart. Divergent boundaries aren't just underwater. In places like Iceland, you can see this process above ground with volcanic eruptions and lava flows creating new land. Next up, convergent boundaries. Here plates collide. If an oceanic plate meets a continental plate, the denser oceanic plate sinks or subducts beneath the continental plate. This creates deep ocean trenches and volcanic mountain ranges like the Andes in South America. When two continental plates collide, neither sinks. Instead, they push up massive mountain ranges. The Himalayas, home to Mount Everest, were formed this way, and they're still growing today. Finally, we have transform boundaries, where plates slide past each other. This movement isn't smooth, it's jerky, causing earthquakes. The San Andreas Fault in California is a famous example where the Pacific Plate and the North American Plate grind against each other. Earthquakes at transform boundaries remind us that plate tectonics isn't just a scientific concept, it's a force that shapes our lives. Plate tectonics also explains Earth's past. Around 300 million years ago, all the continents were joined in a supercontinent called Pangaea. Over time, the plates moved apart, creating the continents we know today, and they're still moving. The Atlantic Ocean is widening by a few centimeters each year, while the Pacific is shrinking. In millions of years, Earth's map will look very different. So why does this matter? Plate tectonics explains why our planet is so dynamic. It's the reason we have mountains to climb, volcanoes to marvel at, and earthquakes to prepare for. It's the story of a living, breathing Earth. The next time you feel the ground beneath your feet, remember, it's not as solid as it seems. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating science content. See you next time.